Hey, my name is Milan, and in this video I'm going to show you how you can introduce distributed tracing into your .NET applications that integrate with AWS. We're going to use a service called X-Ray to view our traces, and in the example we're going to specifically focus on messaging with SQS and SNS. First, I have to start by thanking AWS, who is the sponsor of today's video, and what I want to highlight is their messaging library, AWS.Messaging, that allows you to easily build .NET applications that integrate with SQS, SNS, or EventBridge. Now, why am I focusing on this library? Well, because it also has support for OpenTelemetry, but let me give you a quick walkthrough. So here's a .NET application that integrates with AWS.Messaging, and this is all the code that's required to build an event-driven application. You call add AWS message bus, and behind the scenes, this is going to configure a couple of things. First, your publishers. You can have publishers to specific services like SQS and SNS, where you specify what is the type of message that you are publishing, in this case, an order-created event. But you also have to specify the resource ID where you are publishing to. So this could be a queue URL or a topic URL, or in the console, you're going to find this as an ARN. The second thing after the publishers is the pollers. These are going to be background services that are going to be polling your SQS queues for messages and handing them off to our next component, which is the handlers. So you can connect your message handlers by just implementing a simple iMessage handler interface where you specify the message type. You get the message in a respective envelope, and then you can process it inside of your handler. And all of this is wired up with just a couple of lines of code. However, you are responsible for creating the required infrastructure components. So you have to wire up all of the queues, the topics, and the subscriptions between them. And that's pretty much it. How you publish a message is by using the iMessage publisher abstraction. You can also use the SQS publisher or SNS publisher if you need to send some specific information to these services. And that brings us to our next part, which is how do we integrate this with OpenTelemetry. So there's also an accompanying NuGet package called AWS.Messaging Telemetry, OpenTelemetry. It's still in the early stages, but I tested it out and it works pretty well. And it uses the OpenTelemetry cloud standard, which allows us to implement distributed tracing inside of our .NET applications. We just have to add instrumentation for AWS messaging, and all the heavy lifting is handled by the library. So let's go ahead and try to install it and see how we can integrate it. So I'm going to look for some NuGet packages, and let's go ahead and install the AWS.Messaging OpenTelemetry package. I will add the latest stable version, but we also need a couple of more things. I'm going to look for OpenTelemetry, and here I want to install OpenTelemetry Exporter, OpenTelemetry Protocol. Then I need OpenTelemetry Extensions Hosting, and for example, we can add ASP.NET Core Instrumentation. So let's go ahead and install those, and we can also install the HTTP client instrumentation. So these libraries will allow me to integrate OpenTelemetry directly and also export my telemetry data into an OpenTelemetry collector. We'll get to this in just a moment, but let me show you what you need to add to your code to start exporting distributed traces. You have to say builder services add OpenTelemetry, and then you have to configure the respective signals. So let's, for example, say configure resource, and I just want to configure my service name. I'll say resource add service, and let's say builder environment application name as the resource name. Then we can introduce tracing by calling with tracing, and here I'm going to provide a delegate that's going to configure the specific instrumentation that I want to introduce. So let's say I want to install ASP.NET Core instrumentation, HTTP client instrumentation, and you can also configure AWS messaging instrumentation. So this is what we get with the NuGet package that we just installed. Then we just say use OTLP exporter, and this is going to start exporting our distributed traces into a collector. I will explain what this is in just a moment. But let's also consider how we can introduce some custom instrumentation into our project. I'm going to add a new class in the root folder that I'm going to call diagnostics config. Let's make this a static class, and inside of it, just one static field is going to be a public static read-only activity source, and I'm going to call it activity source, and let's initialize it, and let's give it a name of Amazon Amazon.Messaging. So just the same name as our application namespace. So this is going to hold my activity source, and I want to enable it inside of my distributed traces. So I have to say add source and specify the respective name. I can do this by saying diagnostics config activity source and access the name property. So this is now configured inside of my tracing setup, but I also need to use it inside of my application. So for example, we can add an activity around our handler here. So I'm going to say using var activity, and I'll say diagnostics config activity source, and let's call start activity. Let's give this a name of order created event handler, and for example I can call this process message. Let's add a block statement and just paste in our code, and then we can also use this activity to introduce some additional telemetry data by adding the respective tags. You can access the activity object and call set tag, give your tag a name, and for example I want to include the order ID, and let's also include the order customer ID. So let me add this as another tag. I'm going to call it customer ID, and I just have to pass in the respective value. So this is a simple way of how you can introduce custom telemetry data into your applications. So what is the goal of this? Well, I want to see this information available in the distributed traces that we're going to export using the OpenTelemetry exporter. For now, I'm going to close this down. And then what's the next thing that we need? Well, we need to actually run an OpenTelemetry exporter. So I'm going to add Docker Compose instrumentation for my application. I'm going to scaffold this using Visual Studio, and this quickly gets me a Docker Compose YAML file. Here, I'm going to additionally expose the application ports. So let's expose the port 5001. This is going to be the HTTPS port, and I want to map this to the 8081 internal port in the Docker container. Now, what is the second service that I need? Well, I'm mentioning this OpenTelemetry collector, and this is basically a service that is going to process our distributed traces. And there is a very specific container that I want to run called the ADOT collector. It's short for AWS distro for OpenTelemetry, and it's available as the AWS OTel collector image. I'm going to use the latest version. You have to specify a command for how you're going to configure the OpenTelemetry collector. Then you can mount your configuration file into the respective config file inside of the container. I'm going to explain what you have to specify here in just a moment. And then we have to expose a couple of ports so that we can use this locally. The one that's important for us is 4317, which is the OpenTelemetry receiver endpoint. So how can we use this? Well, this allows me to specify a couple of environment variables. The first one is OTel exporter OTLP endpoint, and I'm going to point this to my OpenTelemetry collector. It's available as ADOT collector, and the port is 4317. This is the gRPC port, and it doesn't hurt to also specify the OpenTelemetry exporter OTLP protocol, and I'm going to specify the protocol value as gRPC. So with this setup in place, our .NET application is going to spin up an OpenTelemetry exporter that we added with this line here, and the exporter is going to pick up on these environment variables and start exporting telemetry data to the ADOT collector. So one more thing remains in our setup, and that's actually authenticating with AWS. I'm going to specify a few more environment variables: the AWS access key ID, the AWS secret access key, and the AWS region. Now you can see that I'm specifying these values as some parameters, and how this works is I have an environment file in my root directory that contains the actual variables. The environment file just contains the .env extension, and you can define your environment variables as key value pairs. Now you're going to replace this with your actual values for the access key ID, the secret access key, and the region that you want to use. When it comes to the ADOT collector configuration, here's the simplest setup possible. It's just a YAML file that configures the three components that are part of the ADOT collector: the receivers, the processors, and the exporter. So let me explain what they look like. The receiver component is where you configure how you're going to receive telemetry data. In this case, we are exposing a gRPC endpoint on the port 4317. The processor component manages how you actually handle the traces or how you pass them along to the exporter. And we're going to use the batch processor that's going to collect a batch of messages and then send them off to be exported. And finally, the exporter component is where you configure where you actually want to send the telemetry data. In this case, I'm going to send them to AWS X-Ray, which is a distributed tracing service in AWS. I'm going to use US East 1 as my region. And lastly, you can configure your tracing pipeline with the free components. So we're going to mount this file as the configuration file inside of our Docker container. And note that this isn't only limited to AWS X-Ray. You can also use it to export metrics and traces from your application into any AWS supported service, for example, CloudWatch or Managed Prometheus. So now that we have all of this configured, let's run our application. From Visual Studio, I'm going to start the Docker Compose project. And if I open up Docker Desktop, you can see my two containers running. The ADOT collector, which is going to accept our OpenTelemetry data, and then we have our application container. I'll send a post request from Postman to our API, and we hit the breakpoint in our minimal API endpoint, where we're going to publish a message using the message publisher. I'll press continue, and you'll notice that we immediately hit the breakpoint in the respective event handler, where we are going to kick off our activity and process the message. So I'm going to remove the breakpoints from the app and press continue. This is going to complete my handler, and we'll go back to Postman. And just for good measure, let's send this request a couple of more times so that we have some additional traces to see in the X-Ray console. So let's go into the AWS portal, and from here you can look for X-Ray, which is going to lead you to the X-Ray console. Now this may look different depending on when you last accessed it, but by default is going to lead you to the trace map view in AWS CloudWatch. So here you can see the couple of traces that were detected by X-Ray, and all of these originated from our .NET application. So let's take a look at this trace here, where you get some timing information about the specific trace, and you can click on this button here to view the individual traces that we have inside. So if I scroll down, we can see all of the traces here, and if we go into one of the traces, we can then see what are the specific spans that are part of this trace. And this is actually a request to our minimal API endpoint. So you can see the URI here, which is localhost 5001/orders. So this particular trace contains spans that represent the HTTP request to our API, but there's also spans from the AWS.Messaging service. You can see that we are running the message to an AWS service, then we are publishing to AWS SNS, and then we have an HTTP request being sent to the SNS service, which you can see right here. Now, if I go back to the traces, and this time I should be looking at all of the traces, I want to take a look at this one here that doesn't have a URL address. This is actually our message consumer, and you can see the message here. So we have a span from AWS.Messaging processing message, and then our custom span that we created with an activity in the order created event handler. So if you open up the sidebar, you can see additional information about the specific span, how long it took to execute, and you can also examine the resources and any metadata that you may have added to this span. So in our case, we added the order ID and the customer ID as additional information on the activity. And this is now available in the traces view in CloudWatch. And one more trace I want to show you is the last couple of traces that you can see here. And one thing that kind of stands out is that all of these traces are around 20 seconds long. Now, what operation inside of our system takes about 20 seconds? Well, if you go into the trace, you can see some post requests being sent. And if you click on this to get some additional information, you can see the request URI here being sent to the SQS queue that we are polling. So this is actually our poller component running in the background, and it's going to be using long polling, where it's going to send a request to this URI to listen for messages, and the request only times out after 20 seconds or when it finds a new message on the queue. This is a more efficient way to poll SQS queues, and the AWS messaging library does this by default. So there you have it. This is how you can integrate distributed tracing with AWS messaging inside of our .NET applications with a very minimal amount of code. And if you want to grab the source code for this video, you can get that completely for free from the pinned comment right below or the video description. If you enjoyed this video, go ahead and smash the like button for the YouTube algorithm. Check out my courses if you want to improve your software architecture skills, and until next time, stay awesome.